Hello everyone. So this is the last test we would like to do in this lesson. So you can see that we are going to talk about the test concerning proportion when we have one population and we are talking about one proportion, and there are two cases, the small versus large. If it is a small sample test, then you will see that we basically use a table in the appendix, and that's it. We don't need to perform we don't need to find the test, we don't need to do any calculation. If it is a small sample size and then we are talking about the proportion, so you can see that the example we have, the germination capacity is at least 80%, and then we used a sample and we say that we used let's say germinate 15 seeds, that means sample size is 15 we have, and the null hypothesis is what we said at the beginning. It's actually 0.8, that means 80% the proportion, and if it is 80%, then the if we use 15, then the germination will be 12. That's what we said in the bracket. The alternative is in one-sided test. You can see that it's less than 0.8, that means not germinated. So that's what we said, and then in using the level of significance 0.05, we have to go to the table A1. So in table A1, lot more things we have to consider. So you can see the sample size 15, proportion is 0.8, and then the value in the table, now we need to find that. Let's go to the table, and then it says the binomial probability table, we have to use that. So in the binomial probability table, we need to find a lot more things. So you can see the proportion, you can see sample size, you can see the x value. Okay. So in our case, we say that the n is 15 probability, the proportion is probability proportion is 0.8, and then the x value is 9, because you can see that in the table we will find that. So that's what I would like to show you, how we can find that value. So you need to find where we have the sample size 15 we used. The sample size 15, you can see sample size, and then the proportion we are using is 0.8. And level of significance for 15, you will find that level of significance we are going to use 0.05. Since 0.05 is not there, the closest one is 0.40, that's what we will use. For that value, what is the x value we find? So for that value, the x value is 9. That means that we have to use 9 as our cutoff point. That means that's the critical value we find. Okay. So using that, we can say that the if it is less than or equal to 9, then we will reject the null hypothesis. Okay. So that's how we can find. And then for if the sample size is larger, then we have to go for a test. The test is z-test again, and in the z-test, basically you need to use the proportion you find in the sample, proportion you find in the population, and then you have to find the standard error for that proportion. If we have the test difference between two proportions, then all you need to do is that you need to use the two proportions, the difference between two proportions, if we are interested to find the difference between two proportions, and then in the population, what's the difference between them, and then the standard error we find for the difference between the proportion. So that's why you will see that we use the whether the proportion are same or not. So that means in our hypothesis we say that they are actually same, and we use one-sided test, and then we use level of significance 0.05. If you go to the z table, then you will see that the z value is 1.645, and then that value is actually for, if you go to the table, you will see that that value is for 0.95, and then from the Z, you can see that we have to use what's the proportion mentioned on the question. So you don't need to think about critically. You can just say that if in the question 2 proportions are given, you can just take the difference between 2 proportions in the sample and in the population, and then use the standard error of them. So you'll see that there are some examples given in the table, in the textbook. You can follow that, and then the value you found, and then value you have in the critical from the Z table. Then you can compare them. So you can see that the critical region is a little bit higher than the Z value you found, the Z statistic. That means it's actually it falls within the acceptance region. It's and then you can say that they are not significantly different. That means they could be similar. So that's it for the hypothesis testing. This is the last part for this lesson. So hypothesis testing for the means and proportion. Then later on I will talk about the lesson 8 and other hypothesis testing. Thank you.